Tonight we'll touch on the effects of climate change on the world and northeastern United States, including the effects on agriculture. I'll attempt to justify the 80% reduction of heat-trapping emissions from 1990 levels by 2050 that has been introduced to the legislature. And also, I'll talk about how to make a difference in heat-trapping emissions. This is a plot of carbon dioxide levels in red with numbers on the left and average global temperature in blue with numbers on the right. The main point with this graph is that temperatures have been accelerating for the last 3 decades. And the temperature is increasing 0.4 degrees Fahrenheit per decade. That may not sound like much, but over time, we'll be overheating the planet. Climate scientists usually address a simulation, such as portrayed here, to make the point that human-induced emissions are causing the warming. The line in black is the observed temperatures over the last 100 years, and the group of lines around that line in black is a compendium of simulations made by climate centers around the world. That top group is with human-induced emissions of greenhouse gases included in the simulations. The bottom group is without the human-induced emissions, natural drivers only, such as changes in solar radiation reaching the Earth. You can see that there's a substantial difference over the last 3 decades, especially between the human-induced emissions and with only natural drivers. That the human-induced emissions follow the observed temperature ranges. The reason that in previous decades, say 20 years ago, even 10 years ago, all climate scientists were not in agreement about whether human-induced emissions were making the changes is because the temperature acceleration had not yet been observed for as long. As shown in the previous graph, the temperature has been accelerating, especially during the last decade, even more than the three decades before that. So now there has been a long period of observations that allow the simulations to separate the effects of human-induced emissions from natural drivers quite distinctly, as can be seen in this graph. However, everybody who's worked with computers knows that they're a little bit flaky. So although I respect these results, and I think that they're plausible, I want to talk about some ways to approach the subject that are more intuitive, even more based on observations. For example, this is a plot of solar irradiance, or power, that has been headed towards the Earth over the last 3 decades. You can see the natural variation due to sunspot cycle, activity of the sun. Every 11 years, that's an 11-year period. But the overall trend for solar power has not been increasing, yet the temperature has been increasing. So how could solar power be driving that? This is a plot of 1,000 years of temperature and carbon dioxide, with carbon dioxide in the red and temperature in blue. The variation in temperature can be seen, it's been very frequently that it's been varying over 1,000 years. But there has been no trend upwards in temperature, such as you see in the last 150 years during the industrial era, that trend upward and as strong as that trend upward. There have been minor trends driven by mainly differences in solar radiation and other effects from the climate. But in the last 150 years, the temperature has really accelerated along with the carbon dioxide. In fact, carbon dioxide has led the temperature during the industrial era. Therefore, it can be a cause of the temperature rise. If temperature had been leading the carbon dioxide level, carbon dioxide could not have been the cause. But indeed, during this last 150 years, in general, carbon dioxide level increases have led temperature. But really, what's so bad about warmth? In New York State winters, we can really appreciate warmth. However, it can be seen that a significant fraction of hurricane tracks make landfall onto the United States. A hurricane is a heat engine driven by the difference between the temperature at the bottom of the storm and the temperature at the top of the storm. A car's heat engine turns the wheels of the car. A hurricane's heat engine turns the atmosphere. When a hurricane's crossing over water, vapor rises in the storm, condensing higher up in the storm, releasing latent heat of condensation. That heat released higher up in the storm drives it even more fiercely. As a hurricane crosses Florida, it may decrease in intensity to a tropical storm. But for those storms that survive as hurricanes over Florida and onto the Gulf, the water vapor from the warm Gulf rising into the storm can drive the storm to a superstorm such as we saw with Katrina. This is a plot of sea surface temperature that correlates very tightly with the power expenditure of hurricanes in green over the last 3 decades. Until the last decade, the increase in power expenditure by hurricanes only increased as a slight trend, slightly, more or less obscured by the natural variation that you see in the graph. However, in the last decade, the temperature of the sea and the hurricane power expenditure have begun to dominate the natural variation. This is consistent with the first graph that we saw of temperature accelerating in the last decade especially. But how could we influence the vast atmosphere? Well, from space, the atmosphere is as thin as the skin of an apple compared to the radius of the Earth. And yet, the heat-trapping gases within the atmosphere comprise, for example, in carbon dioxide's case, just 1/2500th of that thin atmosphere. 380 parts per million, 1/2500th about. And other heat-trapping gases such as methane, natural gas, and nitrous oxide comprise even smaller amounts of the atmosphere. So when we cause the emission of heat-trapping gases, we're influencing the volumes of those gases much more than we influence the volume of the atmosphere. We don't influence the volume of the atmosphere much at all, but we do influence the volumes of greenhouse gases significantly because even though they are a small part of the atmosphere, they have a strong effect on it. In addition, we're now over 6.5 billion people, with everyone trying for a higher standard of living and consequently using more energy. When you step outside, you're stepping into an overcrowded vehicle. with no emergency exit for that population that's continuing to rise. These are the greenhouse gases that we increase. It's significant that methane, for example, has 21 times the global warming potential of carbon dioxide. That means that methane absorbs infrared heat radiation from the Earth and then re-radiates it in all directions, including back towards the Earth, 21 times more effectively than carbon dioxide does so. So, emission of these gases adds further blankets that heat the Earth relative to space. The pre-industrial levels of heat-trapping gases protected the Earth from space. There was a blanket that warmed the Earth from the cold of space. But as we increase those gases, we're beginning to overheat the Earth. When one burns liquid or solid carbon dioxide, one creates a volume of gaseous carbon dioxide over 700 times the volume of the original liquid or solid. And that affects the volume of carbon dioxide in the atmosphere 2,500 times as much as it affects the volume of the entire atmosphere. The climate sees an increase of over 700-fold in volume of carbon dioxide from burning, and an increase by leveraging of over 2,500-fold. That's how we have a significant effect on the atmosphere. Human-induced emissions may be in the process of transforming the climate so that we are starting a chain reaction of feedback cycles. But what is a feedback cycle? This is an example with the water vapor feedback amplification cycle. Human-induced emissions increase levels of greenhouse gases, then greenhouse blanketing increases, increasing the global surface temperature, and then increasing evaporation. And since water vapor is itself a greenhouse gas, that increases greenhouse blanketing and increasing surface temperature again in a cycle. That water vapor cycle amplifies human-induced greenhouse gas emissions until increased precipitation and radiation to space result in a new equilibrium temperature. So as temperature increases, the Earth and the climate, the atmosphere, radiate more energy to space from fundamental physical principles. And that causes the water vapor amplification cycle to slow down and stop again, but at a higher equilibrium temperature. Another example of a feedback cycle is the reduction of ice in the Arctic. As the ice melts, it reveals more water to solar radiation. The water absorbs more of that radiation, and that warms the water, melting more ice in a feedback cycle. That's one reason that the extent of polar ice in the Arctic has decreased more than the size of Texas in extent over the last 25 years. That's unfortunate because in the sediments buried beneath the coastal waters of the Arctic Ocean are methane hydrates or clathrates that are so dense in methane that if you bring a chunk of it to the surface and strike a match to it, it burns. Ice burns like a kitchen stove. Over 100 billion tons of methane are in these frozen hydrates or clathrates buried beneath the sediments in the shallow coastal waters of the Arctic Ocean. They're buried in a thick layer so that they're not all going to melt at once. But if the top layer starts melting, it will begin to release methane into the ocean water, and then that will diffuse into the atmosphere. A 100 billion tons of methane are equivalent to 2,100 billion tons in carbon dioxide in terms of global warming potential. That's over 80 times the annual human-induced emissions of carbon dioxide. We do not want the full thickness of these methane hydrates to melt. That is high motivation to act promptly to reduce emissions. And yet, this possibility is not modeled in the climate centers. It's not in the reports that have been publicized because it cannot be modeled with present-day technology for various reasons which have to do with bringing the Earth scale, the worldwide scale of the model, to the small scale of the ocean waters that are next to the coast. So those coastal waters would have to be modeled quite finely in order to determine when the temperature is going to increase enough to melt the hydrates. So that effect is not modeled, and it represents a tremendous hazard that could help motivate the government to enact legislation, among other possible releases of methane and other gases from feedback cycles. Another trend that's been increasing has been glacial sliding, as measured in the micro-earthquakes that have been accelerating in Greenland. Micro-earthquakes made by glacial sliding. That means that the glaciers are heading towards the coast more rapidly and calving icebergs into the ocean more rapidly. The icebergs float elsewhere and melt. This is an additional contribution to sea level rising beyond the melting of glaciers that have been publicized. That also is not able to be modeled. The glacial sliding, those are measurements that I showed. That's observational data, but it is not yet possible to model the glacial sliding because of the extreme complexity of a glacier. It's brittle on top and then plastic on the bottom because the mile-thick glacier causes the nature of ice to change throughout the glacier. So trying to model that is extremely challenging and is not included in the predictions made. This is a plot of the global glacial volume, which has been losing mass at an accelerating rate for decades, with the acceleration becoming stronger over the last couple of decades. So far, 6,000 cubic kilometers of glacial mass have been lost due to melting. However, a larger fraction of glacial mass might be released if the acceleration continues. It doesn't take a computer model to see where this graph is going, towards the floor. So if that continues to accelerate, a substantial part of global glacial volume might be lost, and that would result in, if it's all lost, then as much as 0.6 meters, about 1.8 feet, increase in sea level. That would mean a substantial change in lifestyle for coastal populations and migrations, quite possibly of millions of people. How about effects in the Northeast? The sugar maple range could need to move north in decades. Ordinarily, the biosphere has hundreds and thousands of years to respond to changes in temperature. In the past, that's been the case. And yet, in decades, with changes occurring in decades, the sugar maples will need to be replanted further north. The reason that maples are so sensitive to temperature increases is that it quite likely, one hypothesis is that the sugars do not get transported so readily at high temperatures from the source leaves into the phloem of the plant to be used by the rest of the plant. So that transportation of sugars is inhibited. Also, the reproductive ability of the plant may be impaired, resulting in infertile seed production. The temperature in the Northeast has been accelerating in the last couple of decades, even more than the temperature towards the equator, because the tropics are heat sources and the higher latitudes are heat sinks. The heat source, the tropics, increase in temperature to a moderate degree. The heat sinks increase much more than the tropics. And that's another reason that the Arctic the North Pole area has increased in temperature so much more than the equator. The winter temperature in the Northeast has increased more than the summer temperature. This is due to the dryness of winter. An additional blanket over the surface of the Earth makes more of a difference in winter because there's not so much water vapor to absorb heat. So the water vapor blanket, say, might be this much, and the additional heat-trapping emissions due to human-induced emissions might be that much. Well, in the summer, the water vapor blanket might be that much, and the human-induced emissions that much still, so that in the summer, those emissions don't make as much difference as in the winter. Therefore, winters increase in temperature more than summers. This results in a decreasing number of snow days. In fact, the largest red dots on this picture represent a decrease of 30 days from 30 years ago. This is bad news for agriculture, counterintuitively. Because, for example, in January, when there was no snow on the ground, we nevertheless had a few days cold snap. And that caused the soil to freeze further down than it would have done otherwise if there had been a snow cover insulating the ground from that deep freeze temperature. Unfortunately, that killed soil bacteria deeper into the soil than otherwise. The soil bacteria normally retain nitrogen in their bodies. However, upon the bodies getting lysed or broken apart, the nitrogen was released, possibly getting washed away from the soil, downstream. This makes it harder to maintain healthy soils, especially with organic agriculture, and might mean that conventional farmers would need to add more fertilizer. The average growing season has been increasing. Again, the intuition would be that that would be good. Well, there's some cultivars for which it's bad. Apple trees need a sufficiency of winter chill days below 45 degrees Fahrenheit to reset for optimal budding and blossoming. The grapevines, the roots may have been damaged by the soil freezing during times when there's been no snow on the ground. The carbon dioxide fertilization effect means that the plant nutrient, carbon dioxide, is at higher levels in the atmosphere, and that means that the plants have an easier time absorbing that nutrient. That, combined with the longer growing season, hypothetically would mean increased harvests. However, the farmers are going to need to spend more money battling plant pathogens, diseases, and weeds. Extreme precipitation events are on the increase. This is an historical plot for the last 100 years, and in general there's been an increase, a long-term trend. In the last 3 decades in particular, extreme precipitation events have been increasing. This can result in field flooding and high wind damage to crops if there's a high wind during that heavy rain. Another problem is that the plant canopy may become denser with higher carbon dioxide levels, but that could cause the humidity to increase beneath the canopy. That might cause increased fungal growth, which would require more applications of fungicide, yet the extreme precipitation event, heavy rain can wash off the fungicide in just 10 minutes. So that would mean more applications of fungicide, yet an expense for the farmer. The green revolution of the 60s may be tapering off. Maybe other factors as well, maybe there isn't as much of a market and so on, but in general it may be tapering off, and it may be even harder to maintain high yields of grains in the future with the rusts, that fungal rusts that grains tend to develop at higher temperatures and humidity. As it is, the high world population is increasing in part due to the plentiful harvests of grains that we've been experiencing. As though if those harvests decrease, the population will be at risk. Pests tend to thrive at higher temperatures because insects are cold-blooded. Even bee populations are getting damaged by mites that attack the bees. But plants are highly vulnerable to increased insect activity, and that insect activity may be harder to counter with pesticides because the reproductive cycle of insects is also increased, so that more generations occur per season, giving the insects an increased opportunity to develop resistance to pesticides. This phenomenon of the source leaves holding more sugar stimulates insects' appetites with the increased sugar levels. So that insects tend to eat more, and then they're also more active. So this is a plot where in blue, with the present day carbon dioxide levels, the amount of leaf tissue eaten by insects is lower than the red bars from the increased carbon dioxide levels. Integrated pest management practices may become even more important so that farmers can avoid some of the expenses necessary for if they were just going to rely on pesticides, increasing pesticides to deal with insects, which may become more robust against pesticides. Weeds thrive at least as much as cultivars thrive with increasing CO2 levels, getting that plant nutrient carbon dioxide. More pollen may get produced with higher allergenicity. This is a picture of poison ivy growing in a test plot. Instead of occasional vines in that woods, the poison ivy is choking the understory. And indeed, there's a higher resin content in the poison ivy for greater allergenicity. This makes it difficult for the researchers to find out what's going on in the plot, to take a survey of other plants. Weeds may become more robust to herbicides with higher carbon dioxide levels. And the test plot in the right was with higher levels of carbon dioxide and denser weeds resulted, even though they're applying the same amount of herbicide. During the summer, there may be more periods with higher temperatures and yet little precipitation. That means that there might be insufficient water to enter the roots and then carry nutrients such as calcium up into the plant. That could cause calcium deficiency and internal rotting in the produce. The reproductive development of plants could be countered, could be reduced and impaired by increased carbon dioxide levels if it's at a higher temperature. So the plots on the right show the bean harvest at a higher temperature, and it can be seen in green there that the harvest of beans is minimal compared to at today's temperature. Yet the plant matter is still substantial in the blue bars. That's because it's the reproductive development that's been impaired by the high temperature heat stress. This is also telling with the rice flour. The rice flour gets damaged with just a minimal increase in temperature of 1 or 2 degrees. It can become much more readily damaged during warmer periods of an extended time while it's flowering, drastically reducing rice harvests. Livestock, if the animals cannot maintain their body temperature and become feverish, then they are not as productive. Farmers get told to select more readily digestible food for lower heat production during digestion. And they are also told to keep the cattle cool. Well, that's a big extra expense. This shows precipitation trends with the large yellow dots indicating areas where it has become dry over the 20th century, and that would continue in projections as the temperature increases worldwide. The message from this graph is that drier lands will become drier with the increased evaporation from increased temperature and the capability of the atmosphere to hold more water at an increased temperature. And the green dots indicate where it's becoming wetter due to the increased precipitation from the more active hydrological cycle. Water evaporates and precipitates more rapidly at higher temperatures. And yet, that precipitation is not evenly distributed. The areas that are already dry may well become drier in general, so that the Midwest and Far West United States could suffer extreme water stress in coming decades. And the same would be true in several countries around the world where crop failures may become more frequent in countries especially that cannot afford to install vast irrigation systems. However, the population is expected to rise to over 9 billion people by 2050. This will represent a challenge to civilization. Bacteria break down synthetic fertilizer to nitrous oxide, which has 310 times the global warming potential of carbon dioxide. So farmers could use plant-based fertilizer instead of synthetic. Also, roots could be left in the ground instead of getting plowed up. Roots being left in the ground, storing carbon. You see the word sequestering as well, storing carbon in the ground. According to the United Nations Food and Agriculture Organization, in their report, Livestock's Long Shadow, livestock farming generates more heat-trapping gases than transportation. How could that be? Well, the types of gases produced during livestock farming have that high global warming potential. And yet transportation produces mainly carbon dioxide. So livestock farming equals or exceeds transportation in emission of heat-trapping gases, with 9% of human-related carbon dioxide being produced by livestock farming, 37% of all human-induced methane, and 65% of nitrous oxide, 64% of ammonia, which may contribute to damaging rain. In addition, over 6.5 billion people today, many of whom are asking for more animal products in their diets, drive livestock to become 40% of the global agricultural output. Farmers are told to capture and burn the methane that comes from decomposition of manure. Well, that doesn't account for the methane from the ruminants' digestive systems, which is the majority of the methane produced in livestock farming. In addition, it occupies 30% of the Earth's entire land surface, mainly for permanent pasture, but also including 33% of global fertile land for producing feed. 20% of pastures are considered degraded through overgrazing, compaction, and erosion, advancing desertification. 70% of the acreage of former rainforests in the Amazon have been converted to grazing so that we can eat beef. Extensive water pollution may be caused by livestock wastes and chemicals. Substantial further health risks may result because animal diseases also occasionally infect humans. For example, bird flu. For all of these reasons, it would be useful to consider full cost pricing for water for agribusinesses, large corporations that increase livestock farming. Also, it would be worth considering eliminating other subsidies to major corporations. Since production of plant-based foods consumes far fewer resources, it's worth pondering the health benefits of increasing consumption of those foods. Animal-based foods could be reduced to less than a deck of cards worth a day. That's a serving. And such personal changes could eliminate over a ton of carbon dioxide emissions per year, saving more energy than switching to a hybrid car. And it's cheaper to switch to plant-based foods than to buy a new car, but could do both. If hundreds of millions of people took these steps to modify personal diet to reduce the consumption of animal-based products, that could make a big difference in the amount of emissions produced by human activities. On the website climatehealth.net are listed 2 books by MDs that support the health basis of the scientific basis for the health benefits of plant-based foods. Yesterday was National Prime Rib Day. How about National Lentils, Rice, Kale, and Walnut Day? Legislation has been introduced to Congress for an 80% reduction in heat-trapping emissions from 1990 levels by 2050, reducing a few percent per year. A political compromise down from that 80% goal could be a climate-related failure, delaying the necessary cutbacks for an unknown number of years as impacts accelerate. The country would likely be awash in expenses arising from impacts, draining the ability to invest in efficiency and renewable energy sources. But governance involves a flurry of scattered, conflicting activities that occasionally result in compromise. Yet this issue demands action as soon as possible to enact the 80% goal. Scientists' published predictions are based on the more conservative results of computer modeling, but modeling is extremely difficult for ice sheet crumbling, methane release from decomposition of melting permafrost tundra, and from methane hydrates. Impacts will possibly accelerate more rapidly and with more severity than predicted. It's even meeting the 80% goal. The world will be fortunate if damages are limited to the published predictions. To increase the chance of avoiding more severe damages, it's imperative to enact laws that have not been compromised from the 80% goal, that meet or exceed that goal. Elected officials do pay attention to the calls and letters received by their offices. Only activism can get the 80% reduction enacted. It's better to inundate Washington with calls and letters than to see Washington get inundated by sea level rising. The Climate Action Partnership is an alliance of environmental groups and major businesses that are urging strong legislation. Businesses such as Alcoa, Caterpillar, DuPont, General Electric, Pacific Gas and Electric, Duke Electric, and Lehman Brothers investment bankers. Major conventional businesses, not alternative businesses, are supporting strong legislation and working in concert with environmental groups to get it enacted. We have allies. Consumers do drive change. As more renewable markets get demonstrated by leading consumers, more businesses will invest in reduction of renewables with economies of scales, increasing efficiency production and reducing costs for the larger numbers of follow-on consumers. The U.S. could take a lead by enacting strong legislation. And an example has already been set of an international agreement on climate change. This was the Montreal Protocol of 1987 that limited the production of chlorofluorocarbons that were damaging the ozone layer that's critical to life. The U.S. could bring China, India, and Australia in by leveraging the economic influence of the U.S. with those countries, bringing those countries as well as the rest of the world into a worldwide agreement on limitation of heat-trapping emissions that are now damaging the climate and threatening the future. What about alternatives to fossil fuel? Well, nuclear power stations are beset with safety problems, primary among which is the possibility of an attack penetrating the confinement vessel of the nuclear power station and causing a release of radiation into the atmosphere. In addition, the spent fuel rods from nuclear reactors contain plutonium that can be extracted from the rods to make nuclear weapons. So, as countries around the world increase the number of nuclear power stations, that means that it could also increase nuclear proliferation of weapons. Therefore, we don't want to set an example of building a lot more nuclear power stations. We don't want to set that example to the rest of the world. In addition, those stations are incredibly expensive and usually have extreme cost overruns. And as I mentioned, consumers do drive change. consumers can send a message to businesses to produce products with a smaller carbon footprint. In addition, it's possible to direct all of one's payment for electric supply to energy service companies that supply that electricity based on renewable energy. I've written an article on that subject, the steps to go through to redirect the electric supply payments to renewables, 100% of those payments. That article is on the website climatehealth.net. In addition, I've written an article on how businesses can do well, doing good, by profiting in a sustainable world, no longer the infinite world that the world was thought to be in previous decades that could be infinitely depleted, but a sustainable world, and how businesses can profit in a sustainable world. That article is on climatehealth.net. Consumers can make a major change in their energy bills by buying a boiler that is more efficient than the present boiler if that boiler is over 15 or 20 years old, since the majority of energy expenses are due to the heating and cooling of the house. Other appliances could get replaced by more efficient appliances as well. Get Energy Smart is a good reference for that on the web. More information on that subject. In addition, the handouts and an article again on climate health detail a number of steps that people can take to make changes in their personal lives to reduce emissions of heat-trapping gases. A lot of information about passive solar buildings is on that website, climatehealth.net. Of course, transportation is a major source of emission. So it's worth noting that over 55 miles an hour, we're paying considerably more for that transportation and emitting considerably more gases than necessary. Keeping the tires optimally inflated is free. It just needs to be done more often. And getting the vehicles tuned up and the air filter exchanged more often could make a difference as well in mileage. What about futuristic fixes? Proposals have been made to put a space solar shield between us and the sun. Well, the Earth's disk is 100 million square kilometers about in extent. To block 1/2000th of that disk would take a 50,000 square kilometer disk, or a number of shields that comprise a total of 50,000 square kilometers placed in the equilibrium gravitational spot between us and the sun, and maintained in that spot against solar radiation. That's an impractical proposal. In addition, we've invested many trillions of dollars in the infrastructure to burn carbon dioxide. It would almost certainly take many trillions of dollars to separate the diffuse carbon dioxide from the atmosphere and put it underground, the carbon dioxide that is, and put it underground to force a significant enough amount of the atmosphere through dense membranes, separate out that carbon dioxide, and then sequester it would be very energy intensive and would need to be done on a large scale, surely costing many trillions of dollars. And there'll always be competing demands for funding. It is necessary, of course, to capture the concentrated carbon dioxide from smokestacks and put that underground. Futuristic fixes such as the space solar shield and carbon capture by filtering out the diffuse carbon dioxide are dangerous distractions from the important work that's at hand. The important work of increasing in energy efficiency, investing in coal-powered power stations that are capable of carbon capture and sequestration, storage. Those investments are necessary, and we need to make those without being distracted by futuristic fixes. It's not often that everyone has a chance to save the world and save money doing it by increasing energy efficiency. Occasionally throughout history, a generation is faced with a crisis. Let's not say future generations can take care of it. We, not the children, are the generation faced with this rapidly emerging crisis. We need to address it by reducing emissions as soon as possible, to as great an extent as possible, for a stronger, more energy independent United States, and for the children. It's up to us.